In this video, we're going to talk about a pattern that we use to relate our classes. This design pattern is called composition. So we use this design pattern to create a relationship between our classes. In this case, to implement a has-a relationship between classes. What I mean by that is the following. If we look at inheritance, as we looked at before, inheritance uses the is-a design pattern. Meaning, if we have, for instance, right here, we have vehicle, which is a parent class, top class here, we would say, and then at the bottom we have car, we would say car is a vehicle, meaning car is of type vehicle. Okay, that makes sense. So there is this relationship of inheritance. However, if we're talking about composition, now we have a different relationship, which we call the has-a pattern relationship. So if you look at, for instance, a bathroom class, and at the bottom we have a tub class, and below that we have a bubble class. Now, the bathroom class has a tub. In the real world, if you look at this, a bathroom usually has a tub. However, we cannot say that a tub is a bathroom, nor can we say bathroom is a tub. The same way goes, we understand that a tub has a bubble, meaning that a tub could have water with bubble. But a tub is not a bubble, nor is bubble a tub. So you notice now we have decoupled all of these relationships that we have between bathroom, tub, and bubble classes, meaning they don't have to inherit from anybody. But we can use this composition to correlate these classes. And how do we do that? We use instance variables that refer to other objects. For instance, in our bathroom class, we could have an instance variable or a member variable of type tub, as you can see in the diagram. If we had a sink class, we could also create that member variable and call this the sink. Now we have a way to implement the sink as well as the bathtub, okay? Because we have this relationship of a has-a, because a bathroom has a tub. And that's how we relate those objects, by referencing them through their instance variables. The same thing we can do with our tub, right? So inside of our tub, we know that tub has bubbles. That means then we can have an instance variable of type bubbles inside of our tub. So now, instead of our tub object, we can reference bubbles. So we were able to create this composition as opposed to using inheritance. And there are a few benefits to using composition. The first one is code reuse, less dependency between these entities, these classes, and flexibility, meaning that we can now easily replace implementation of each class, right? Because we know, for instance, bathroom has a tub and also has a sink, which means we can just go to a tub class and change things and everything else will still work, okay? Now let's go ahead and look at this example in code. Let's go ahead and create a new project. In this case, I'm going to be using IntelliJ, but you're welcome to use any other IDE that you would like, such as Eclipse. I'm going to go ahead and say File, New Project. Of course, I'm going to make this a Java project. Say Next. I'm going to create an entry point. Say Next as well. I'm going to call this Composition. And Next. Make sure this is, and there we go. Now I have my new project. I'm going to go ahead and create 3 classes. Okay, I'm going to right click. I'm going to say Java class, and I'm going to call this bathroom. I'm going to create another one, tub, and also I'm going to go ahead and create the last one here called bubble. Okay, let's start with our tub class. I'm going to create private, and then I'm going to say private. And using the idea of composition, I'm going to create a tub instance variable. So I'm going to say tub as such. I'm going to just call this bath tub, like that. And for now, I'm going to go and create a few getters and setters. So I say Command N, getters. First, let's say getters and setters like that. Create a getter and setter for size. Say OK. And there we go. So we have a getter and setter for size, and that's fine for now. Let's go ahead into our bubble class. Say private int radius string, and I'm going to call this color as such. All right, so I'm going to say control N, getters and setters. I'm going to select both and OK. Very nice. So we have our bubble and we have our tab classes respectively. For this case here, I'm going to create private. It's going to be bubble. Just call it B as such. So inside of our tab, we know that tab has a bubble. Literally, now our tab has this bubble interface or this bubble instance variable that will allow us to access our bubble class. So now here, what we can do, we can go ahead and create, for instance, a constructor, which allows us to construct our tab object. So what we can do here, we can create a constructor to construct our tab class. So we can go ahead and say command new. I'm going to say constructor. In this case, I'm just going to pass in the size int to construct it like this. Now, inside of our tab constructor, we can easily go ahead and say b. What is this b? This bubble here, right? Is equal to new bubble. So I'm instantiating this bubble object inside of our tab constructor here. Okay, so when the tab is constructed, when we create this object, we will also be able to construct our bubble object as well. So now that I have our b, I can say b dot, and I can then access all of the other functions or methods or getters, as you can see here. We can say set color, I can say blue, right? I can say b dot set radius, an integer 23. If I go to our main here and I say instantiate my tub here, I can go ahead and say, for instance, tub, my tub is equal to new tub as such. Now you notice I have to pass an integer because our constructor requires so. We can go ahead and pass in, for instance, 13 like that. Dot out dot println, say my tub dot get size as such. I'm going to go ahead and save and run. We should be able to see 13. Now, if I go back to my tub here, notice we have set up bubble because we're talking about composition here. Now, to be able to then access the get and get color and get radius, we can create another getter here. We can say public. It's got to be string. We can say get bubble color. So get bubble color, and I can just say return reference to our bubble class. I can say B. Now I can access the bubble getters and setters, right? I can say get color, for instance. So now if we go to our main again, inside of our print out here, I can actually add space, and I can call again my tub, and look at this. I can say that get bubble color. If we save this and run, we should see here 13 blue. Okay, so this is a very basic example of composition in Java. You notice that we didn't have to inherit from anybody, from any other class. Inside of our classes, we included as a member variable, as an instance variable, bubble type variable here, right? And inside of our constructor, we instantiated our bubble type, and we set the color, set radius, turning our get color from our bubble object or bubble reference here. This is the idea in composition, okay? Because as you can see here, notice that we use tub and bubble. So we know that tub has a bubble. As you can see here, we're saying literally that tub has indeed a bubble. Now, my challenge for you now is to do the same thing that we did here with our bathroom and refer back to the diagram that I showed you, the relationship that we have between bathroom, tub, and bubbles, right? Because bathroom, in this case, has a tub has a bubble. So in this case here, what I would need you to do is to create the same composition pattern between bathroom, in this case, and tub. just like we did here. Take your time, go ahead and rewatch the intro video to this lecture so you understand the concept here and take a stab at it. All right, I'll see you next.